Well, hi guys. We're going to do parametric equations and polars and vectors with this next unit. And so we're going to start with parametric equations. The basics, we're going to do some slope and some arc length. And parametric equations are basically how to graph non-functions, things that do not pass the vertical line test. And parametric equations will have two equations. You're going to have two variables, x and y, and they are going to be typically in terms of a third variable that represents time. So you're going to have x as a function of time and y as a function of time. So let's do an example of sketching one. So let's sketch x equals t squared minus 4 and y equals 1/2 t on the t interval from -2 to 3. So what we're going to want to do is set up a table. T, x, and y. We're going to let t range from -2 to 3, so -2, -1, 0, 1, 2, and 3. And we're going to plug these values into our different equations. So our x comes from t squared minus 4. So x is going to go 0, -1 squared is 1 minus 4 is -3, 0 squared minus 4 is -4, 1 squared minus 4 is -3, 2 squared minus 4 is 0, and 3 squared minus 4 is 5. Do the same thing for y, except we're going to use the y equation. Y is 1/2 t. So that's going to go -1, -1/2, 0, 1/2, 1, and 3/2. And so what we have here is a way of sketching this curve with respect to time. So we're going to have the point 0, -1, then we'll have the point -3, -1/2, and then -4, 0, and then -3, 1/2, and then 0, 1, and then 5, 3/2. And what we can do here is sketch this little smooth curve, but we can also indicate direction. See, we began when time t equals -2, and we moved along this curve in this direction. So we can put little arrows and tell you, what happened. So it's a way of introducing a third variable or time into a two-dimensional picture. Okay, we can also do something called eliminate the parameter to get it into something that you are more used to. My pen is being weird. Eliminate the parameter. And the parameter means get rid of t and put it in x's and y's. So we had our equations x equals t squared minus 4, and we had y equals 1/2 t. So what we can do is just solve one equation for t and just plug that in right there. So if we plug that in, we'll get x equals 2y squared minus 4, and we get the equation of that sideways parabola, that non-function that we were looking at earlier. So, parametric equations allow us to graph non-functions and introduce a third variable. Let's do another example of eliminating the parameter. Let's consider like x equals 3 cosine t and y equals 4 sine t. This will be another example here. Just the basics. And so what I can do is divide both sides by 3, get that in terms of cosine, and then divide both sides by 4 and get that in terms of sine. And I can use that equation from trig that says cosine squared plus sine squared is equal to, does anyone remember? Yes, that equals 1. So I can substitute this in, and I get the equation of an ellipse centered at the origin, and it is up and down 4, because the square root of 16 is 4, and that's our major axis, and then right and left 3, that's our minor axis. And there's our ellipse. So there's another example of eliminating the parameter. Okay, so let's go to slope. Now to find slope, we want to find, if I have some curve like the one that I had earlier, slope is picking a point and finding the slope of the tangent line at that point. And slope is represented by dy dx. But if we have t's, the way we find our slope is we do dy dt divided by dx dt. And in this form, you'll notice that those dt's would cancel, and that's how we find the slope. So let's do an example of that. If I have let's start with x. X equals cosine t, and y equals sine t. Let's find dy dx. So we are going to say that dy dx is equal to dy dt divided by dx dt. So the derivative of our y equation with respect to t, the derivative of sine is cosine, and then the derivative of our x equation with respect to t is negative sine. And so we get, this is negative cotangent t. Let's do another example of that. Let's do x equals the square root of t and y equals 1/4 t squared minus 4. And we want to find, there my pen goes again being silly. Alright, let's find dy dx at the ordered pair 2, 3. So what we're going to do first of all is we'll find our dy dx. So dy dx is dy dt over dx dt. Okay, so the derivative of this y equation, if we multiply that 1/4 through there, we get 1/4 t squared, and so the derivative of that is just 1/2 t. And then the derivative of the x equation is 1/2 t to the negative 1/2. And this would simplify to just t to the 3/2. But what do we plug in for t? I mean, this is an x and a y. So what we're going to need to do is we're going to have to figure out what that t is, and we've got to hopefully make sure that they're have the same t value. So the x coordinate is 2 and the y coordinate is 3. So let's see what t values make them at the x coordinate 2 and the y coordinate 3. Well, if we solve this first one for t, we get t equals 4. And if we solve the second one for t, I'm going to get t equals plus and minus 4. So we're going to use the same value for t, which is positive 4. And so this is going to be 4 to the 3/2 power. The square root of 4 is 2, and 2 cubed is 8. So that's the slope at that point. Okay, now what about the second derivative? The second derivative has notation d squared y over dx squared. And the way we get this with our t is we are going to d dt our dy dx and then divide that by dx dt. If you play around with these fractions here, you'll see why those are equal. So let's do that with our example we just had. If we d dt our dy dx was t to the 3/2. So that's going to be 3/2 t to the 1/2. And then if we divide that by our dx dt, which was 1/2 t to the negative 1/2, we are going to get, those 2's are going to cancel, we're going to get 3t. And so we can find our second derivative evaluated when t equals 4 is going to be 12. So that's like our concavity. All right, let's do the last thing was going to be arc length. Arc length is how to find we've done this before, we just haven't done this parametrically. Your arc length formula is going to be the integral from a to b, and these are t values, by the way, t equals a to t equals b, of the square root of dy dt squared plus dx dt squared. So let's do that example from our very first one. the arc length of that first graph we drew, that when it went like this, we can actually find how far this particle traveled on that curve by doing this formula. And it was from, if you remember, it was from -2 to 3, or if you just want to look back, I guess, of the square root of dx dt squared. Now let's go back and look at that. What was the x equation? The x equation was t squared minus 4. So dx dt is 2t. So dx dt squared is 4t squared. And dy dt is 1/2. So dy dt squared is 1/4. So let's go take a look at how that would look in our formula. So this would be 4t squared plus 1/4 dx. And we can plug that in our calculator and figure out how far that went. Alright, well that's pretty much the basics in slope and second derivative and arc length. So I will see you guys tomorrow.